Today we're going to learn the concept of increasing and decreasing functions. So to know this concept or concept what we know need to know from the 11th is that like if you have a line drawn rising, it rises, you have to look always from the left to right. Why? Because left is the negative numbers, right is the positive numbers. So when you look from the left to right, if the line is rising, we say that the slope which we had learned, that is y2 minus y1 over x2 minus x1, the slope is going to be positive. That's for a rising line. And if the line is falling, the slope of this is going to be negative. This is the concept which I'll be using here, which you learned it in 11th. So increasing and decreasing function. I know that you're well aware of the concept of increasing, what that increasing and decreasing mean. But just to tell you, suppose if I have a graph, a continuous graph like this, something like this way. Yeah, this way. I have a graph like this. Okay, so this is the turning point. You can see that there's a turn appears. Let's take that turning point as A, and that turning point is B. Okay, so now very clearly we know that increasing is from, that is, this is the graph where it's increasing. I'm just drawing it in red. That's increasing, and this is the one where it's increasing. Okay, and decreasing is when this is the one where it's decreasing. So we know that very clearly. Okay, so that's how the intervals of increasing and decreasing are. But when you're given a question, it's not possible for you to always draw the graph and tell what is increasing and decreasing. Because if you have a graph given, you could do that. But it's not possible always to draw the graph. So now we are going to learn today mathematically how to find the increasing and decreasing interval. Okay, so first, to find the increasing and decreasing interval, first you have to learn how to find A and B, the turning points, where the points appear. So to find A and B, the uh, turning points, what can you do? Actually, you can. It's something which you learned it before in Rawls theorem. Remember, f dash of c equal to 0. I told you that in Rawls theorem, that theorem gives me the turning point. So at the turning point, understand that the derivative, the derivative f dash of x is equal to 0. So when you equate the derivative to 0, that will give you the turning point. Why? Because it's parallel to the tangent is parallel to x-axis. That is why x-axis slope is 0. So that is why we know that it's parallel. So the slopes are equal. That's equal to 0. So that's how you find A and B. That is the turning point. Okay. Now turning points, we call turning points as, mathematically we call critical points. So from now on, I would be saying critical points instead of turning points. Please keep as a note. Mathematically, we call it critical points. Okay. So you find the critical points A and B. Now, after you find the critical points A and B, how to understand it's increasing and decreasing, we have to use this concept. That is, f is increasing in closed interval AB if f dash of x is greater than 0, and decreasing with f dash of x is less than 0. I'll tell you why. Because if you look into this increasing, when you draw the tangent, when I draw the tangent is going to be just, yeah, tangent just touches and goes. Yeah, the tangent is like this. So you can see that the tangent is rising. It's a rising line. As I told you in the last slide, it's a rising line. So rising line means slope is positive. So in that case, your f dash of x is greater than 0. So here, see, here also, when it's increasing, the tangent, when you draw it, it's a rising. So f dash of x is greater than 0. That is what is being told over here. If f dash of x is greater than 0, the function is increasing. And when you draw the tangent for a decreasing, you could see that the tangent is falling. It's a falling line. That is f dash of x, as I told you before, if it's falling, it's less than 0. The slope is negative. F dash of x is less than 0, f is decreasing. Okay, you can connect like this. Increasing, as a concept say, increasing. Increasing means positive. The slope is positive. And as for the word decreasing, the slope is negative. That's how you understand that uh, whether the graph is increasing and decreasing. Don't get confused. So only two things from the slide you just need to know how to do it. I'll show it to you. Don't get confused. Only two things you need to know, that is how to find the critical point. Critical point is found using f dash of x is 0. Okay, that's one thing. Just understand. Next thing, the second thing to understand is that if it's increasing, derivative is greater than 0. If it's decreasing, derivative is less than 0. Just understand these two concepts from the slide, and how to do it, I will show it in the next slide. The next concept is strictly increasing and strictly decreasing. I'll tell you the difference between the previous slide. It was just increasing and decreasing. Here it is strictly increasing and strictly decreasing. I'll tell you the concept. So let me draw the same graph as I drew before. Same graph. Let's take it as A. The turning point as B, which is found by using derivative is equal to 0. Okay. Now, if it's increasing, not strictly decreasing and strictly, I'm just telling the concept of increasing. So we know that this is negative infinity and this is positive infinity, because negative numbers on the left side, positive numbers on the right side. So here it is, here you could see that here it is increasing, and from B to infinity, that is increasing. So the intervals of increasing you write as minus infinity to A close to A, okay? Or, so instead of or you write union, because there are two intervals of increasing. B to infinity. B is closed, infinity is open. Minus infinity and infinity is always open. Why? Because we don't know the value of minus infinity and infinity. We don't know. It's a like minus infinity is a very small number, but we don't know that value. So that's why we can't include that value. So it's always open bracket for infinity and minus infinity. Okay. So is increasing and decreasing is when it is A to B. You could see that A to B, it's decreasing. So close interval A to B is decreasing. That's how you write the intervals for increasing and decreasing as per the previous slide. Now, when it comes to strictly increasing and strictly decreasing, what the change is that minus infinity to A open bracket, that is critical points becomes open bracket. That's the only difference. B to infinity is strictly increasing, okay, and open bracket A to B is strictly decreasing. So when it comes strictly, you actually have open brackets for the critical points. That's the difference. Why? Because why here it's open bracket? Because at A, at over here, it's neither increasing nor decreasing. Neither increasing nor not decreasing, because it's a turning point. And at B, it's neither increasing nor decreasing. So when it comes to strictly increasing, that is, it has to increase. That is why we don't include the critical point, because at the critical points, it's neither increasing nor not decreasing. Understood? So that is why when it comes strictly increasing, we don't have the critical points included. Only the bracket changes, but the concept is the same. Find the intervals in which the function f given by f of x is 2x square minus 3x is increasing and decreasing. So first you got to solve for the critical points. So equate the derivative to 0. So derivative of f dash of x is 4x minus 3 equal to 0. I found the derivative of this. Now, 4x is equal to 3. There is only one critical point, 3 by 4. So that makes a lot more simpler. So minus infinity to infinity. So the point is 3 by 4. There's only two intervals. So you take a point from here, and see if it's positive or negative derivative. So f dash of say f dash of 0 is a good better point over here. Going to be 4 into 0 minus 3. That's negative 3. So it's decreasing. Now f dash of, take a point from here. So I can take f dash of 1. So 4 into 1. I can take any point. It's a choice what to take. So it's going to be 1. So it's positive. So I can say that minus infinity to 3 by 4 close is decreasing, and 3 by 4 to infinity is increasing. So find the intervals in which the function f of x is given 4x cubed minus 6x squared minus 72x plus 30 is increasing and decreasing. So first you have to find the critical point, the turning points. So to find the turning points, equate the derivative to 0. The derivative of this is going to be, we know that it's 12x squared minus 12x minus 72 equal to 0. Now I need to solve for x. So this is the quadratic equation, but I think you can divide by 12. It makes it much more simpler. And then when you factorize it, you would get, splitting the middle term, you get x minus 3 and x plus 2, because minus 3 and 2 gives me the sum as minus 1 and product as minus 6. So x is equal to 3 and x is equal to minus 2. So minus 2 and 3 are the critical points. So when you draw it, the concept is that minus 2 and 3, at minus 2 and 3, minus 2, 3, you have the critical point. So either the graph is like this, I don't know, I'm just telling it. Either the graph is like this, goes like that. One second, sorry. Yeah, either the graph is like this, that is at minus 2 and 3, there's a turn, or the graph could be this way, one of them. That's going to be the shape of that. Okay, we don't know what's happening. So now we need to decide what's happening over there, whether it's increasing or decreasing before and over here. So we have to decide which kind of graph is that. So now what you do is that to decide, you take it as a number line. So we draw the number line, that is the x-axis. Okay, and we know it's here it's minus infinity, and this is infinity. And as per the number line, negative numbers comes first, and then 3 would come next. So you take a point from this interval. You take a point from that interval. Any point. You can take minus 3, minus 4, minus 5, minus 6. So, and you substitute the derivative. So you're checking whether the derivative is positive or negative. So let me take this f dash of minus 3. So now when you substitute, you can substitute it here, you can substitute it here, or you can substitute it in the simplified form, because all those are derivatives simplified form. But I would substitute it over here because this is a better form. It's easy for substitution. Otherwise, I'll have to find the square, x, multiply with 12, all that I have to do. So minus 3 into minus 3 plus 2, that's going to be minus 6 into minus 1, that's 6. So it's greater than 0. So I can conclude that it's increasing over there. Now f dash of, I take a point in this interval. Okay, please understand that never take minus 2 and 3. Never take minus 2 and 3. You have to take the points between that. Why? Because at minus 2, you will be getting, f dash of x as 0, because when you equate to 0, you got minus 3 and 2. So you will be getting derivative as 0. So to decide if it's increasing and decreasing, you have to get this greater than or 0 or less than 0. So you take the points only between. You would not take minus 2 and 3. The critical point is not taken. So f dash of, you can pick any number, minus 1, 0, 1, 2. I would say 0 is better, because then you can get rid of x over there. 0 minus 3 into 0 plus 2, that's minus 6. That's less than 0, so it's decreasing. And f dash of, take the point in another interval from here. So that's going to be f dash of 4. That's going to be 4 minus 3 into 4 plus 2. That's 1 into 6, that is 6, greater than 0. So it's increasing. So now writing the interval, increasing is going to be minus infinity to minus 2, close bracket, union 3 to infinity is increasing, and minus 2 to 3 is decreasing. If it was strictly increasing, strictly decreasing, it would have been an open bracket over here for the critical points. That's the difference. Okay, so understand that. That's how we solve it. So this basically understood, it's increasing over here. So the graph is something actually like it's increasing there, then it decreases, and then it increases. So that's the shape of the graph. But that's just, you don't have to draw it, but I was just telling you. So here, see, it's positive. That is why the slope is positive. Well, that's why its derivative is greater than 0. Here it is negative. That's why it's less than 0. and it's positive. That's why it's greater than 0. Okay. You're not to show the graph, but I'm just telling you the thing. Find the intervals in which the function f given by f of x is equal to 2x cubed minus 3x squared minus 36x plus 7 is increasing and decreasing. So the first you have to solve for the turning points, the critical points. So you have to equate the derivative to 0. So derivative of this is going to be 6x squared minus 6x minus 36 equal to 0. Now you have to solve for x. So you could divide by 6. So x square minus x minus 6 equal to 0. Splitting the middle term, you get x minus 3 into x plus 2 equal to 0. So x is equal to 3 and x is equal to minus 2. So over here, now you can draw the number line and arrange the numbers as per the number line. So minus infinity, infinity, minus 2, 3. So now let's check what is happening in between these three intervals. So let's take the points from those intervals. Let's take from the first interval. So let's put f dash of, I can take any number, f dash of minus 3. Let's substitute to the derivative that is over here, which is in the better simplified form. So minus 3 into minus 3 plus 2. That's going to be minus 6 into minus 1. That is 6. It's greater than 0. So therefore, we can conclude it's increasing over there. Now, f dash of a point from this interval, 0 is a better option. So 0 minus 3 into 0 plus 2. That's going to be minus 6. That's less than 0. So it's decreasing. Now, from that interval, so f dash of 4, it's going to be 4 minus 3 into 4 plus 2. That's going to be 6, which is positive. So it's increasing. Therefore, we can write the intervals that is minus infinity to minus 2 included, or union 3 to infinity is increasing, minus 2 to 3 is decreasing. Show that y is equal to log of 1 plus x minus 2x over 2 plus x, x greater than minus 1 is an increasing function throughout the domain. So you have to find the derivative. So f dash of x, that's going to be derivative of log of 1 plus x minus derivative of 2x over 2 plus x. So log of 1 plus x derivative will be 1 by 1 plus x minus, you have to use the quotient rule here, 2 plus x into derivative of 2x minus 2x into derivative of 2 plus x over 2 plus x the whole square. So 1 over 1 plus x minus 2 plus x, derivative of 2x is 2 minus 2x into derivative of 2 plus x is 1 over 2 plus x the whole square. So 1 over 1 plus x minus, opening it up, you get 4 plus 2x minus 2x, 2 plus x the whole square, 2x gets cancelled. So 1 over 1 plus x minus 4 over 2 plus x the whole square. Now trying to make the denominator same, I can multiply this with 2 plus x the whole square, this with 2 plus x the whole square, and this with 1 plus x and 1 plus x. So opening it up, 2 plus x the whole square is 4 plus x square plus 4x minus 4 multiplied, it's minus 4 multiplied to that. So it's going to be minus 4x over, common denominator is 1 plus x times 2 plus x the whole square. So that's going to be, the 4x gets cancelled, 4 gets cancelled, x square over 1 plus x over 2 plus x the whole square. Now I can find the critical point, that is equate this to 0. So x square over 1 plus x times 2 plus x the whole square equal to 0. X square is equal to 0, so x is equal to 0. So the number line, you draw the number line, it's greater than minus 1, so you understand that it's minus 1 to infinity. So 0 falls in between, and then you take the point from here, show that both are increasing, which I'm not doing it. I find it is a bit long way because I can get the answer from here without doing all that. I'll show you how. Okay, that's this is an alternative way. Okay, there's an alternative way. You have the regular way of doing finding the critical points as the usual way. But when you find the critical points, please understand that the number line is from -1 to infinity. You have to take care of that interval. Okay. Now, from here, how can you do is that just we know that x square is positive. That is, this term is positive. 2 plus x the whole square is positive. 2 plus x the whole square is positive. Since squares are positive because you are squaring it. Squares are positive because they are whole square. And also we know that 1 plus x is positive. 1 plus x is positive. You know why? Since x is greater than -1, it's given over here. X is greater than -1. Therefore, 1 plus x has to be positive. This implies I can say that f dash of x is always going to be positive because each term is positive over there. Therefore, it is an increasing function. Done. You can also do it like this. Fine. If you're not sure about this way of doing, you can just find the critical points as usual and then find it. In both the intervals, it's going to be positive. Now prove that y is equal to cosine theta over 2 plus cos theta minus theta is an increasing function for theta in 0 to pi by 2. You find dy by dx derivative. That's going to be d by dx of cosine theta over 2 plus cos theta. Sorry, d by d theta because it's terms of theta. Sorry for that. Minus d by d theta of theta. So now over here, we have to use the quotient rule. So 2 plus sine theta, 2 plus cos theta into derivative of cosine theta minus cosine theta into derivative of 2 plus cos theta over 2 plus cos theta, the whole square, minus 1. Derivative of theta is 1. So now 2 plus cos theta into derivative of 4 sine theta is 4 cos theta minus 4 sine theta into derivative of 2 plus cos theta is minus sine theta over 2 plus cos theta, the whole square, minus 1. So opening it up, you get 8 cos theta plus 4 cos square theta minus 4, sorry, plus 4 sine square theta over 2 plus cos theta, the whole square, minus 1. So I can take 8 cos theta, I can take 4 common. So cos square theta plus sine square theta, which is 1 over 2 plus cos theta, the whole square, minus 1 equal to minus 1. So it's going to be 8 cos theta plus 4 over 2 plus cos theta, the whole square. Make it the denominator same, that 1. I can multiply with 2 plus cos theta, the whole square, over 2 plus cos theta, the whole square. I'm trying to make the denominator same. So 8 cos theta plus 4 minus 4 minus cos square theta minus 4 cos theta. I opened up with the minus and opened up the square also. Over 2 plus cos theta, the whole square. That's going to be the 4 and 4 gets cancelled. So it's 4 cos theta minus cos square theta over 2 plus cos theta. So now, as we did over here, we can equate this to 0 and solve for theta. That's one way of doing. But otherwise, what you can do is that you can take cos theta common. And from here, I can conclude the answer and can say it's positive. That is cos theta, that is this term. See, this term is positive since theta belongs to 0 to pi by 2. It's in the first quadrant, so cos theta has to be positive. Now 2 plus cos theta, the whole square is positive, hence squares are positive because it's a perfect square, are positive. And 4 minus cos theta is positive because theta is between 0 and 1. We know that's minus 1 and 1, but since it's 0 to pi by 2, it's between 0 and 1. So 4 minus any number between 0 and 1 is going to be positive. So since again theta belongs to 0 to pi by 2. Therefore, I can say that f dash of x is greater than 0, therefore increase. Or you could do by finding the critical point. You divide the number line. The number line is from 0 to pi by 2. So 0 to pi by 2, not negative infinity to infinity. 0 to pi by 2. Solve for the theta and then do it. That's another way of doing. Okay. So you can try that way. Fine. So this is how we do it.